okay, in the midst of the thoughts I was having which were annoying me and my brain was disconnected, I come out which I think is the best I've ever written or said about this topic. I walk in, teach this topic, put this is what this is, explain it to people, say this is why it works, show people, and it's like 5 to 10 minutes later, if not the next day, it's like they don't know why did that work? Okay, so then I went this, so I really need your brains connected on it. How do I get the gradient at this point? That's the graph of, I've gone through y equals x squared plus 1. So how do you graph that? You put in 0, you get 1, you put in 1, you get 2, and you can draw your parabola. You should know, draw your basic parabolas. How do I get the gradient? I start with y equals x squared plus 1, I differentiate it, what do I get? 2x, the 1 becomes 0, and I want the gradient for x equals 1, which is substitute, and I get 2 times 1, and I get a gradient of 2. Now, for some reason on some graphs, it's very hard to get the derivative. So you can't use the derivative to get the question, you have to use an approximation to get the gradient. You have to use the approximation. So how can we get an approximation to that? If I use the point 1.0, I'm going to go stupid here, 1.001, I can't draw 1.001. I just can't draw it. Could I draw 1.01? Yeah? So, by the way, how far is it from 1 to 1.01? And that's called the change in x. And you've seen that symbol before when we did first principles, and I don't really want to talk about first principles. So in this question, the change in x is 0.01. So we're talking about small changes. I should say small changes in x. And how do you say small changes in x? You put this little delta sign, delta. So we're doing small changes in x. So if I did a small change in x, what do I get for y? A small change in y. Let's calculate. So on this question you go, why would you even use that method? Because I show you the dumb simple question on it. So this will be, so what would we get? Y when we substitute x as 1.01. Ben, if you grab your calculator or whoever's first, we're going to go 1.01 squared plus 1. Oh, I know 101 squared. 2.0201. Say again, 2.0201. 0201. So this point is 2.0201. I hope this is painful for you. And you sit there almost going, so in the moment you just go, oh, just do that. Ready? What do I got to do to get the gradient? Rise over 1. So to get the gradient, I've got to go y2 take y1 over x2 take x1. There's my y2, 2.0201, minus my y1, which was 2. So if I could draw a little diagram there, I've got 2 points like that. I've done a little right angle triangle, I've got the rise over the run. I can't draw it. I've been thinking about ways of zooming in and doing it. This will be 1.01. Well, she can't afford to be distracted. You really can't. You can, but she can't. The x2 value is 1.01 minus that. How many could have done that in your head? So that's 0.0201 over what? And Ben's going to say to us the answer is? What is it?
You wrote 0.1.
Oh, 0.01. Thank you, Ben. Josh?
2.01.
2.11. What was the
2.01.
2 point? Oh, I was worried when we went 2 point that. What was the real gradient? 2. What's our approximation for the gradient? 2.01. Was that pretty good? Nice to have you shake in there. It's pretty impressive. So now what you can do is you can apply that to some horrible cases that you can't differentiate. So if we wanted to now, we could go to a graph that you've never seen before and then apply that to it because you didn't know how to differentiate it. Now we go to the rule and we give some questions. You right? You need to write some notes about it to take that into your brain. So all I did was get 2 points very close together, and I said the distance between those 2 points is 0.01, and that's a small change in x. So, by the way, conclusion, here's the formula. If I can't get the y to x Watch it, Cara. If I can't get the y x, I can approximate it. Do you know that's approximate? I can approximate it using a little bit of y over a little bit of x, and that's your formula. And that's what my brain thinks all the time. Ready? We'll do some questions. So if I can't get the gradient, I can approximate the derivative by getting a little bit of y over a little bit of x. What do I mean by a little bit of y? There was my little bit of y there, and there's my little bit of x there. Okay, the rise over the run, and that's the little y over there, little x. So that's your formula that we're going to use over and over again. Now we do an example.